Hi everybody, hope you're doing well as usual. We're going to begin a new unit on sequences and series. This will probably, looking at what we have left in the year, to about half of it, and then I'd like to finish up with limits, which is some of the stuff you need for calc as well. Okay, so beginning with this first section here, first part, I'm actually going to break up section 1 into 3 parts and 3 assignments as well, because it's there's a lot going on. Okay, so we're going to talk about sequence. What is a sequence? Well, when we think of just that term sequence, we think of things like numbers like 2, 5, then 8, then 11, and then 14. That's a sequence of numbers, and if it goes on forever, we say it's an infinite sequence. Okay, and that's kind of what we're going to look at is more of those types of things. But in general, what does it mean here mathematically? Well, it's a function whose domain is the set of positive integers. Well, what does that mean? Well, it's because we think of these as terms. Each one of these is a term, and this is the first term, this is the second term, the third term, and so on, 4th, 5th, 10th, 100th term. And so the reason it says its domain is the set of positive integers, we're going to plug in this 1, 2, 3 into a function eventually, which we're going to call the nth term. So we use a notation, okay, to represent terms, and we say a sub 1, a sub 2, a sub 3, a sub 4, ... keeps going, and we say the nth term. Okay, so again, what does that mean? This means the first term, a sub 2 is the second term, and then a sub n is going to be our nth term, and really what that is going to be the formula that guides our sequence, something like n plus 2 or n squared minus 1, something like that. You'll see in the next couple examples. But what I needed you to first understand is when I say a sub 1, I'm referring to the first term. If I said a sub 10, that's the 10th term. Okay, that's what it means. All right, so for example, up here, my 5th term is 15. I would say a sub 5 is 14. Sorry, 14, not 15. All right. Okay, so let's look at some things here, just kind of straightforward, kind of plugging in things. It says find the first 4 terms in each sequence. These are what we refer to as nth term formulas, okay? And it's how we define them by an nth term. So when I say the first 4, I just want you to plug in 1 into this term. And so what do we get there? 5 minus 1 is 4. Okay, so the first term is 4. A sub 2. Well, that's 5 times 2 minus 1. So 5 times 2 is 10, minus 1 is 9. And then the third is 5 times 3 minus 1. Well, that's 15 minus 1, that's 14. So the third term is 14. And the fourth term is 5 times 4 minus 1. And that gets me 19. And you can just write it like that. You can write A1 is 4, A2, you don't have to write all the work. You could also write it as this when I ask for the first 4 terms. 4, 9, 14, 19. That's our first 4 terms. Okay, so that's all I'm asking you to do is just plug in. It's really simple. It just looks complex with all the formulas and stuff going on here in the notation. All right, so this one here, just a couple things I want to point out here is negative 1 to the 1. Well, what happens there? So we get 2 plus negative 1, because negative 1 to the 1. So for the first term, I get 1. All right. Second term, 2 plus negative 1 to the second. And what does that do? Well, that gives me a positive 1. So then my second term is 3. All right. So now we go to the third. Well, that's 2 plus negative 1 to the third. So that's 2 plus negative 1, because negative 1 cubed is still negative 1, and we get 1 in that case. And so then we go to the fourth term, the final one, 2 plus negative 1 to the fourth. Well, negative 1 to the fourth is going to give you a positive 1, and so we get 3 again. So you notice the first 3 terms in this case, it goes 1, 3, 1, 3. Notice the pattern. What's causing that is this thing here. Okay, What's causing that is that -1 to the power of n. What you got to realize here is odd powers will make it negative. Even powers will make that answer positive. You're gonna see that a lot with different things going on with sequences now and later. So keep that in mind. All right. All right, so this is just another one. In fact, what I would suggest you do here is pause this and go ahead and plug in the first four, 1, 2, 3, and 4, and see if you can get the first 4 terms. Okay, so let's see if you did pause it and you tried that out, if you got these right. All right, so this is going to look like this. Oops, that's a 1. -3, so -2 to the 1 is -2. All over 2 minus 3 is -1, so that's going to give me a +2. Okay, so then we're going to plug in 2. -2 squared, 2 times 2 minus 3. -2 squared is going to give you a 4. And then this is 4 minus 3, or 1, so we get 4 on that one. All right, the third term, -2 to the third, is 2 times 3 minus 3. And -2 to 3 is a -8. This is going to give me 6 minus 3, or 3. And we could leave it like that. We could get as a decimal -2.6 repeated as well. All right, last term, fourth term, -2 to the fourth over 2 times 4 minus 3. Well, -2 to the fourth is going to give you a +16, and this is 8 minus 3 is 5. You could leave it as that, or what is that, 3.2. Okay? All right, so hopefully you got those answers correct as well. All right, now this, I'm going to tell you this, that I'm going to give you a couple of these in the book. We'll do a couple of these, but you know, if this was normal setting, we would do these in class and stuff, but test-wise, I don't usually give them to you because some people see them, some people don't. So we're going to talk later with specific sequences coming up with the nth term and give you ways to do it, but when in general, it sometimes can be tricky. All right, so what do I mean by that? Well, what we got to remember here is this is our n, our terms, right? This is the first, second, third, and fourth, and sometimes I like to write it like this. And so what you have to look at is, what am I doing to these n's to get these answers? In other words, what did I do to 2 to get 3? What did I do to 3 to get 5? What did I do to 4 to get 7? And it has to be the same things, because some of you might say, well, 2 I added 1, and 3 I added 2, and 4 I added 3. Yeah, but that doesn't help me get an nth term. Okay, what did I do to each of these numbers that gets me these answers every time? Okay, well, in this case, if I take and I multiply the n's by 2, so 2 times n, what happens? Well, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. If I take that and then minus 1, I get the answers here that I wanted. All right, so try that out. 2 times 4 is 8, minus 1 is 7. 2 times 3 is 6, minus 1. So you kind of have to think about it, looking for the patterns. This is all about just kind of patterns, playing around with the numbers. If you struggle with this, it's not as big a deal. I'm only going to give you a few in the bookwork section to try. But, you know, go ahead and try those out and see if you can get it. But they are a little tricky. All right? Maybe pause and see if you can get number 2 here. It's a tricky one as well. Think along the same lines here. So I would do this. Again, I like to see it and then write what the answers are below. You could just write it above these numbers here as well. So what did I do to 1 to get 2? What did I do to 2 to get 5? 3 to get 10? 4 to get 17? You might be thinking along the same lines. Oh, I multiply by 3 and then add 1. Multiply 3. No, it doesn't work. Well, do this for me. Take these n's and square them. What happens? Well, you get 1, you get 4, you get 9, and you get 16. Do you see any connection to that and those? Well, yeah, maybe not. Anyway, if you take n and square it and add 1, that will give you those answers. Look what I get. 4 squared is 16 plus 1 is 17. 3 squared is 9 plus 1 is 10. Again, these are tricky. Some of the other ones are a little easier. Okay? I got one more for you. part of it's easy, the other part's a little tricky, and again, it's not as big a deal. All right. So what is this one? Look at it again and see. I'm going to put underneath just to save myself some time. So these are my ends. So this is 1, 2, 3, 4, 5. If there weren't negatives here in front of the 1/2 and the 1/4, this problem is easy, right? Do you see it? Why? Well, it's just 1 over n, isn't it? This is 1 over n, 1 over n, 1 over n, and you can see that. The problem, so that part's easy. The part that's a little tricky is this negative. Notice it's positive, negative, positive, negative. Well, how does that happen? Well, we saw it previously. If I take a negative 1 power to the nth, what happens when n is 1? Negative 1 to the 1 is still negative 1. What happens when n is 2? Well, negative 1 squared is going to be positive 1. And again, negative 1 third, in other words, when n is 3, gets me a negative 1 again. Notice it switches signs, positive or negative, positive, negative, positive. Now, that's not exactly what we want here. This was when n is 1, I get a negative, and I want a positive. Well, how could I change that? Well, instead of this, what if I had that? All right, so what if n was 1? Well, that's negative 1. 1 plus 1 is 2, and that's a positive. Watch what happens when I have 2. Negative 1, 2 plus 1 is 3, is a negative. So that's what should go in front there. Okay, a little bit tricky, that idea. They're switching signs back and forth, but that's how it happens, either with an n on a negative 1 or an n plus 1. Okay. All right, the last little section, and this first video is probably the longest of the 3 in terms of material. I don't know about time, but in terms of material, it's probably one of the longest. All right, and the reason is this last section is called the recursive sequence. This is not an nth term definition. This is recursive. This is actually how you kind of define sequences and looked at them before. Like when you looked at patterns, you add 3 every time, or you multiplied by 2 every time. You define the sequence using the previous term. All right, now there's something else with recursive. I have to tell you what the first term is, or the first couple terms. And then this is what's given to you. A sub k equals 5 times a sub k minus 1. I know that looks really tricky, but what it is saying is this. To find a term, any term, I'm going to take 5 times the previous term, the one before it. This tells me one before it. Okay? All right. So that's what that means. So if this was a k, this is k, and this is k minus 1, this is the one before it. If I changed it slightly, I could have done it this way. And that's the same thing. It's saying to find the term, I take 5 times the previous term, because this term and then this one over here, the n is 1 less than the n plus 1. Okay, so that's what it's saying when you have this recursive sequence. So I know the first term is 2. If I want to find the second term, well, I'm going to go 5 times the first. Well, that's 5 times 2. That's 10. If I want the third term, I'm going to go 5 times the second. Well, that's 5 times 10. That's 50. If I want the fourth, that's 5 times the third. That's 5 times 50. That's 250. If I want the fifth, this did say the next 5 terms, so I'm going to have to keep going here. So 5 times the fourth, that's 5 times 250 is 1250. And then finally, if I want the sixth, that's 5 times the fifth is 1250. Oops, jumped ahead there. Is 5 times 1250, which is 6250. Okay, let me give you another one and show you why the recursive sequence is even something we look at. Let's look at it in a little bit different terms. So I'm going to say a sub 1 is 5, And we're going to say, I'm going to do it in a slightly different notation, and I'm going to say 8 plus, or no, I'm going to write it the other way. I'm going to say a sub n plus 8. Okay? All right, let's think about this in a different way instead of writing it out. What is this saying? This is saying to find the term, I'm going to take and add 8 to the one before it. All right, in words, term equals 8 plus previous term. Okay, well, here's my first term. What am I going to do to that one to find the second one? I'm going to add 8, so that's 13. All right, what am I going to do to find the next one? I'm going to add 8. 8 plus 13 is that 21. Then to get the next one, what am I going to add to this one? 8. That's 29. What am I going to do to get the next one? Add 8. That's 37. Do you see what I'm doing here? I'm going to add 8. That's 45. The beauty of a recursive sequence is I can quickly get the first 5 terms because all this is telling me to do is add a number to the one before it. Up here, I could have done this quicker. It's saying multiply 5 times the one before it. Okay, so we'll play around with that a little bit. We might have to come back to it. It can be a little tricky at times. So when we get into this, and it's the one part we're not in school and we wouldn't do, I would spend a little bit more time with Fibonacci. I think I am going to create a little something for you guys to investigate with Fibonacci later on, maybe at the end of this unit, something special to look at and different things. Because Fibonacci sequence is kind of a unique sequence. Okay, first of all, we defined it here recursively, and this looks a little strange. But what this is saying is to find any term, you take the 2 previous terms and add them together. Okay, so I like to just do this one in terms of writing it out as a sequence, not kind of grinding the workout. Notice they did start with a 0 term. That's something we do look at from time to time. We start with 0. It'll make more sense later. So the first 2 terms are 1 and 1. To get the next one, I'm supposed to add the 2 previous. So that's 2. To get the next one, I'm going to add these 2, 1 and 2. So that's 3. To get the next one, I'm going to add, that's right, 2 and 3. So that's 5. To get the next one, I'm going to add 3 and 5. So I get 8. And then I'm going to add the 2. You get in the pattern, 13. I'm going to add again, what is that, 21, 34, 55, 89, blah, 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 blah. Okay, now, I'm not going to spend the time now, but just quickly, briefly, I'm going to show you something. Fibonacci sequence is pretty neat. It's found in nature. There's a lot of things that these are found in nature, these numbers. Okay, so if we go, I have it here somewhere, we can see in nature that the Fibonacci sequence comes up. How? Well, look at that. How many petals? 5. That's a Fibonacci number. How many petals? 3. 5. How many petals here? 1, 2, 3. Oops, I clicked on it. Sorry about that. 1, 2, 3, 4, 5, 6, 7, 8. Fibonacci number. If you look at these petals, if we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Fibonacci number. It continues to come up in nature. This one here is going on, and again, I'll do this more later. Again, the number of petals here is, I'm not going to count them, but they're Fibonacci, but then there's these spirals of petals, if you can see them. Well, if you count them, the one direction there's 8, the other direction there's 13. It's another Fibonacci number. Okay, pine cones, a little hard to see here in this type of pine cone, but again, the spirals here that you get, they're also Fibonacci's. But if you look at the top of a pine cone, sometimes I've done this, there's like one little petal, the next one there's 3, the next one there's 5, the next one there's 8. They just work out to be Fibonacci. It's over and over and over again. We'll look at some other areas where Fibonacci comes up. All right, that's what we're going to start the next time. So we're going to end it right there. We're not going to do much with Fibonacci right now. We'll come back to it at some time. It's more about the recursive concept. And